Welcome to the deep dive. Today we're bypassing Silicon Valley, going way back to look at the secret history of calculation tools.
Way, way back.
Right. And these aren't just gadgets. We're talking about the engines of early civilization, things that completely changed how people trade, govern, and even think.
Exactly. And that's our mission for this deep dive, to trace the technical evolution of these tools and focus on the specific problems they help solve.
So where do we start? Mesopotamia.
We start in Sumer, around 2700 BCE. They had this prototype abacus, basically a clay board.
Okay, a clay board. Sounds simple.
It sounds simple, but the crucial thing here is the system. It used a 60-base positional system.
Positional. So where you put a symbol changes its value.
Precisely. That was the huge leap. It let them handle large numbers and fractions in the same calculation, which was, essential for complex trade.
That's a huge step in abstract thinking, but it's fascinating how different the approaches were. You look at, say, Egypt.
Right. Egypt used a simple sandboard. It was a 10-base system, but it was non-positional.
And that's a massive limitation, isn't it?
A huge one. For every new order of magnitude 10, 100, 1,000, you needed a brand new symbol. It made large, complex calculations almost impossible.
So you really can't build an empire on that kind of math.
You can't. Now, contrast that with China's counting rods, the sanchou.
Okay, the counting rods. Now, these were a whole different ballgame, right?
Completely. They used a refined decimal positional system.
Which sounds technical, but what did that actually let them do? Could they handle genuinely advanced math?
Oh, absolutely.
Yeah.
The rods conquered problems far beyond simple arithmetic.
Yeah.
We're talking square roots, solving linear equations.
Wow.
Yeah. Capabilities that, rivaled Western mathematical advancements many, many centuries later.
Yeah.
It just accelerated their science and engineering.
And speaking of acceleration, what about portability? That seems like the next big hurdle.
It was. And that brings us to the Roman hand abacus around the 1st century BCE. You could argue it was the world's first truly portable calculator.
So a merchant could just carry it with them.
A merchant, a soldier, anyone. It was this beautiful metal plate. And what's really insightful is it had special columns just for handling the 12-base system in their currency and weights.
Like the 12 ounces in a pound.
Exactly. It solved the constant frustrating problem of converting between different standards, making it fast and error-free.
Let's shift back to China for a moment, to the one everyone pictures, the swan pan. The abacus with beads on wires.
Right. And there's been a recent discovery there, a prototype from 59 BCE, which pushes the timeline back by decades.
So what did that new technology unlock?
A massive commercial explosion. The speed and efficiency of the swan pan solved the problem of large-scale accounting that had been bottlenecking trade.
So groups like the gin merchants
Could suddenly manage these vast cross-Eurasian trade networks. International finance, even. The swan pan made it possible.
And that impact ripples out, doesn't it? It's not just about commerce.
Not at all. In China, using the rods in the swan pan reinforced this powerful idea of a decimal positional system, a mathematical revolution.
And you see a similar thing in Europe, too, with learning being sort of democratized.
For sure. In the 13th century, you see the rise of abacus schools in Europe. They were training ordinary kids from commercial families in practical math, not just the elite.
But there's an angle here that I think is the most surprising, the social impact.
I agree. It's how these skills actually open doors for women.
Which is not the first thing you think of with an abacus.
Not at all. But you have these powerful examples like Ban Zhao in the Eastern Han Dynasty, or much later, Wang Xini in the Qing.
And they were using these tools for...
What? For advanced astronomy and mathematics. They were achieving incredible success in fields totally dominated by men, directly challenging the gender norms of their time.
So these simple-looking tools provided a real platform for intellectual achievement.
They absolutely did.
So we've traced this journey from Mesopotamian clay to global commerce. And it's clear these weren't just gadgets. They were foundational to, well, everything.
It's an incredible story. And it leaves you with a final thought for everyone listening. The Chinese art of abacus calculation, zhusuan, is now recognized by UNESCO.
And it's still being taught today.
Yes, in over 130 countries. It's taught as a cognitive skill to improve memory and focus. So the question is, what does it mean that this ancient tool is still a living technology offering our modern brains timeless benefits?